Hai, Assalamualaikum dan salam sejahtera. My name is Nurul Herani Afida binti Muhammad Arifin, DF200156. I will present part of introduction. First thing, we all must know what is numerical. Numerical analysis is the branch of the mathematics and computer science that develop analysis and implements algorithm for numerically solving continuous mathematical problems. In this section, we will look at the most fundamental method for solving a linear algebra system known as Gaussian elimination. Gaussian elimination method is the best method and it could solve this kind of problems based on the concept that it can be extended to n linear equation with n unknowns. And then the objective of the project are acquire a basic training in the numerical resolution of the governing equation in the fluid dynamics, consolidation of the mathematical formulation of phenomena of fluid dynamics, and knowledge of numerical integration methodology. Thank you.
Assalamualaikum and good afternoon. My name is Shaziman Bisraini and I will discuss about literature review. So first of all, what is reactor? Reactor can be simple as a small kettle or complex as a large vessel with jacket or coil for heating and cooling, ports or nozzle for material addition and removal. Commonly feature temperature, pressure, pH and other sensor. Using the numerical technique, this study simply cover the unique solution where A is a square matrix for the vector mass balance equation. In this study, we use numerical approach of system linear equation will be used to analyze the mass balance equation for reactor to solve three simultaneous linear algebraic equation for unknown consideration by utilizing Gauss elimination method. So the filler table consists of facts, idea, learning issue and action. So first of all, we make a decision to study the rate of chemical transfer via each pipe is equal to the flow multiplied by the concentration of the reactor from which the pipe came. So idea is to calculate using Gauss elimination method. Learning issue is to find the value of flow rate in cubic meter and find the value of concentration in milligram unit per cubic meter. So the action is analyze the subject from a variety of perspectives by doing in-depth analysis of relevant issue. So that's for all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Ain Samsudin. Now I will present about methodology. For the methodology, I will present first about flowchart. First of all, we are finding topics for our project title. Next, we are create the problem statement in civil engineering and do a research about background study and problem statement. Third, we are identify approximate method and solve the problem by using Gauss elimination method. And next, we are discuss the method and calculation result. And this, lastly, we are doing conclusion about the approximate method that we are used for finding x, which is used Gauss elimination method. We need to do some steps. First step is we need to do the row operation below on row 2 of equation 3.1 to eliminate x1 from row 2, which is R2 of equation 3.1. And step 2, we need to do the row operation below on row 3 of equation 3.1 to eliminate x1 from row 3 of equation 3.1. And then after that, after step 1 and step 2, we will obtain the new value of matrices. And then for the step 3, we need to do the row operation below row prime 3 of equation 3.1 to eliminate x2 from row prime 3 of equation 3.2. After step 3, we get the new value of matrices of A. And then for the step 4, we need to use back substitution to solve for x1, x2 and x3.
Assalamualaikum, my name is Siti Hamizah binti Ahmad, DF200137. I will present calculation. This is water supply system. Reactor 1, reactor 2 and reactor 3 connect with the pipe. Firstly, we need to obtain mass balance equations for reactor 1, reactor 2 and reactor 3. This is equation 1, equation 2, equation 3 for 3 of reactor. And then we got Gauss elimination method. For the first step, we need to eliminate C1, which is 5 C1 in the row 2. And by using these equations, for equation, we got C1 as in 0 value. After that, we need to eliminate C1 from row 3, which is negative 60. And we need to use equation 5. And then, for the last step, to eliminate C2 from row 3, we use equation 6. And we got negative 95 to 0 values. And the last step for Gauss elimination method is we need to back substitution for equation 7, 8, and 9. So firstly, we need to eliminate by using equation 9, and then 8, and then 7. And then we got values for C3, C2, and C1. And lastly, we need to calculate chemical transfer out rate for reactor 3 by using Q multiplied by C formula. And then we got 904.3950 milligram per second. And then that's all for me. Thank you.
Assalamualaikum, my name is Nurul Nazira binti Junaid and my matrix number is BF200151. Today I would like to present the discussion and conclusion. Discussion. We decided to use the Gauss elimination method to solve the problems that relates to pipe install. This method is suitable to solve these problems because this problem consists of 3 systems of linear equation with 3 unknown concentration values. In our lifestyle, this method could solve any kind of problem such as in the healthcare and financial field. In healthcare field, for example, doctors and nurses frequently employ linear equation to determine medication dosages. In financial field, linear equations are frequently used in financial jobs, which is widely used by accountants, insurance underwriters, and loan officers. The next part is conclusion. Based on the observation, we can conclude that the Gauss elimination method is the best and easy method to understand among the rest. The Gauss elimination technique is a direct approach for solving a system of linear equation because it allows us to solve the given system of linear equations in a finite number steps. In order to generate an efficient answer, the younger generation must employ mathematical methods in their daily lives. In conclusion, to address an issue effectively, we must employ advanced thinking capabilities. That's all from us. Thank you.